Good afternoon. Good afternoon. Good afternoon. എന്താണ് റെസ്പോൺസിബിൾ? Good afternoon, students. Where are we? Hello. Hello.
Yeah, good afternoon, sir.
Okay. എന്താണ് താമസം? എന്തോ അല്ല, ഒരു സൗണ്ട് ഒന്നും ആരുടെയും കേൾക്കാനില്ല. കുറെ നേരം കഴിഞ്ഞ് ഞാൻ ചോദിച്ചതിന് ശേഷമാണ് സൗണ്ട് വരുന്നത്.
പോയതായിരുന്നു, ഒന്ന് കേറിയിരുന്നത്.
All right, so we'll start. So we had basically covered most of the topic. Few things are left in physical geography. We'll take that. Few things are left in the resource geography, like energy crisis and things. We'll take that. Meanwhile, we'll first try to, since we have a continuous day to day, we'll try to complete these couple of topics. That is, first of all, we'll look at biogeography. Now, this is the first time I'm coming into the physical part. So the rest of the three realms we have studied, that is hydro, land, ocean, and water has been studied. Now the combination of all these three is the biogeography, where we'll be studying about mostly about the distribution of life on planet, plus a few things about soil. That would be what covered under the biogeography part. Then here obviously you'll have something like soil is a very important topic here. Often questions are repeated. You will see in the last few years also, you'll see a lot of questions being asked from this particular part of the subject. Similarly, you will also see good number of questions from the distribution of plants and animals, factors affecting distribution of plants and animals and their distribution pattern, which is what we call as the zoogeographical zones. Different zones are there where plant varieties are found. There is faunistical zones and there is floristic zones. There is faunistic zone. Video no stuck ആയിട്ടാണല്ലോ വരുന്നത്. എന്താണ്? Okay, let's see. Yeah, so floristic and floristic regions. Then social forestry. Forestry is a small topic, not much of questions as such as asked. Major gene pool centers. Gene pool centers, few questions have been asked. No, in fact, just one question have been asked. That is last year. Last year there was a question in 2021. There was a question. Besides that, not much of questions from the gene pool centers and forestry. Very few questions. Deforestation, a lot of questions are being asked. We'll see that, and the continuation of it of the biogeography part is what we see in the environmental geography, where the main concern is about the basics of environment and ecology till now, and then some of the issues faced by or some of the environmental issues the world is facing today that is being discussed. With respect to environmental geography, the questions are rather more kind of random, we must say. One must say, like, it is not following a particular pattern. For example, in the biogeography, we know, like, soil ഏതെങ്കിലും കാര്യങ്ങളെ കുറിച്ച് ചോദ്യങ്ങൾ റെഗുലർ ആയിട്ട് ചോദിക്കാറുണ്ട്. അതുപോലെ അസംബ്ലേജ് സോൺസിനെ കുറിച്ചും റെഗുലർ ആയിട്ട് ചോദ്യങ്ങൾ വരാറുണ്ട്. But the same cannot be said about environmental geography. So we'll be able to cover few basic things. We'll not be exactly able to predict the topics that is going to come. Biogeography ആണെങ്കിൽ നമുക്ക് predict ചെയ്യാം. Right. So we'll go with respect to that regard. In that regard. Okay. Now we'll start our discussions on biogeography with genesis of soil, or rather just say soil. Soil. Now this topic would be covering few things like there would be what is soil, method of soil formation, that is known as a soil genesis. Then you will have soil classification. These three would be the most important topic that we are going to see today. All right, so we'll start. So what is soil? എന്താണ് soil? Familiar topic ആണല്ലോ, just say it. Yeah, what is soil? ആർക്കൊന്നും പറയാനില്ല? Yeah. Weathering of rocks from soil. Okay. Soil is that particle that is formed by weathering, for sure. Yes. But what is soil? Soil can be simply defined. There is no complex definition here. Soil is the outermost layer of Earth's surface, which is unconsolidated. And then it's not consolidated, it's just lying like that. Then it is maybe organic or unorganic. It could be or combination of the both, right? Which is supporting biological activities. So this is a simple definition of soil. So it is that outer layer of the Earth's surface which supports the growth of biological activities. Not just the growth, but the other animal activities are also supports. Now, soil can be seen with respect to several dimensions. Several aspects are there when you talk about soil. Some of them are soil has different properties. Soil has components of soil. Okay, there are various minerals that are found in soil. There are organic matter that is found in soil. The soil has different colors. Soil colors are there. These are the properties of the soil. Okay. Properties of soil. There are different colors that soil has. There would be black colored soil. There would be red colored soil. There would be yellow colored soil. There would be ash gray soil. Different kind of soils are there. So roughly speaking, if you look at the color of the soil, black or dark color is normally associated with prevalence of high humus content. Humus means organic materials, plant, dead animals. Okay, something like that, or maybe it could be because of presence of in some peculiar minerals. Say minerals. Take the case of black soil. Okay, it's because it's a basaltic soil in the black soil region of India. So normally speaking, black color is a reflection of high humus content. Now there is light colored soil. Light colored soil എന്താണ്? It's mostly lack of humus. എല്ലാ സോയിലും ഒരേപോലെ ഓർഗാനിക് കണ്ടന്റ് കാണത്തില്ല. ഓർഗാനിക് കണ്ടന്റ് കുറവുണ്ടെങ്കിൽ we'll consider them to be what do you call as no, the color will be little lighter grayish color. Now red color would be there. Reddish color is associated with the presence of ferric components. That is iron and iron related things will be giving it the reddish color. Now if you look at in peninsular India, most of the regions of peninsular India would be red soil. Maharashtra plateau would be having black soil, right? Red soil. Now this red soil is because what these regions are very shield region. We have seen that old peninsula shield region, and they are also incidentally the richest source of iron. The Karnataka region, the Chotanagpur region, we know, and that necessarily implicates that the soil is rich in iron, and that's obviously the reason why the soil has a reddish color. So that is red. Now there is other factor, that is texture of the soil. Okay. Now the texture of a soil can also be classified in different methodologies. Like texture would be talking about the size of the soil. Okay. Now based on the decreasing size of the soils could be coarse gravel, no, large size soil, fine gravel, coarse sand, silt, and clay. So these are the four or five categories. Now coarse gravel would be the size decreases. Okay, the coarse gravel will be like gravel. Gravel അറിയാലോ കല്ലാണ് pebbles and കല്ലാണ് pebbles അല്ല pebbles താഴെ വരുന്ന കല്ലുകളുടെ പേരാണ് what you call as gravel. So gravel would be coarse, which is relatively dictated by the details, but for now coarse gravel would be of larger size. Clay would be where the soil is like clayish, ചെളിയ like കുഴഞ്ഞിരിക്കുന്ന അത്രയും what size കുറവുള്ള particles on clay. Silt will be silt and coarse sand will be the normal soil that you find, which is like manal പോലെ ഇരിക്കുന്ന soil. മണലിനകത്ത് കൂടുതൽ കല്ലുകൾ ഉണ്ടെങ്കിൽ that will be coarse gravel or fine gravel. When it is more composed of sandy material, it will be coarse sand or silt. Okay, this is basically the texture of the land, of the soil. Now you have soil structure. Soil structure would be composed of several things. For example, soil structure would be different. There would be what blocky soil. Now, soil structure would be talking about the aggregation of soil particles that combine to form along with organic matter. Aggregation soil particle combines to form along with organic matter. So ഈ സോയിൽ എങ്ങനെയാണ് നമുക്ക് കാണുമ്പോൾ അതിന്റെ ഷേപ്പ് എങ്ങനെയാണ്, അതിന്റെ സൈസ് എങ്ങനെയാണെന്നുള്ളതാണ് സോയിൽ സ്ട്രക്ചർ പറയണേ. അതിന്റെ സ്ട്രക്ചറിന്റെ ഡീറ്റെയിൽസ് ഒക്കെ നമുക്ക് പോകേണ്ട അധികം കാര്യമില്ല. So basically it would be like there are different ways in which soil is around. If you look at blocky soil, there would be different blocks. Soil would be found as blocks. Then there would be on the other hand crumbly soil would be there, where soil would be more like this part. Okay, I think soil structure എന്താണെന്ന് പഠിച്ചാൽ മതി, അതിന്റെ കൂടുതലും ഇതിലേക്ക് പോകേണ്ട കാര്യമില്ല. Then another factor that soil has which is relevant is the pH of the soil. That is acidity of the soil. If soil is acidic or if it is basic, that needs to be known. Then you have the idea of soil profile. ഇത്രയും കാര്യങ്ങളാണ് നമുക്ക് ആദ്യം നോക്കാനുള്ളത്. Soil profile refers to the vertical arrangement of soil column. So there will be soil. We'll come to this later after writing all those things. So soil, how this is the rock structure, the underlying rock structure, or the non-weathered rock, as you may call it. And in between these region, how soil is arranged. There will be one layer, there will be second layer, there will be third layer. So this is how soil is arranged between. This is the surface layer, the O layer, and beneath that there are different layers. How these layers are arranged, that is what soil profile is. So ഇത്രയും കാര്യങ്ങളാണ് നമുക്ക് നോക്കേണ്ടത്. സോയിൽ പ്രൊഫൈലിൽ നമുക്ക് സ്റ്റാൻഡ് അലോൺ ക്വസ്റ്റ്യൻസ് വന്നിട്ടുണ്ട്. UPSC has asked standalone question as to what is soil profile. So we'll write till that point, then we'll discuss what is soil profile and things like that. And obviously depth of soil is there, that we'll see along with soil profile. All right, so we'll write a few things till now. Just a second. Okay, that's fine. So we'll start. We'll start by defining the soil. Soil refers to the outermost unconsolidated layer consolidated layer of the earth's surface which may or may not be having biotic components or interrelation. So that is a short definition of soil. Then we'll write a few words about soil. A couple of sentences also can be written. Soil is a very dynamic resource. Soil is a very dynamic resource. As it is adjusting, as it adjusts, as it adjusts to various natural and man-made changes. Man-made changes acting upon them. Okay. Let a few things of properties of soil. Soil color. Black color is attributed to the presence of humus. Attributed to the presence of humus. Sometimes it can also be due to the presence of inorganic minerals. Normally organic nature ondana. Sometimes it can also be due to the presence of inorganic minerals. Example, black soil. Black soil of India. Is low in organic matter, but has black color due to its formation from basaltic rocks. Okay. ബാക്കിയുള്ള കാര്യങ്ങൾ ഞാൻ പറഞ്ഞ പോലെ ഇത് എഴുതിയാൽ മതി. Light color is due to little humus, normally found in desert regions. Desert regions ആണ് humus content ഏറ്റവും കുറവായിട്ടുള്ളത് വരുന്നത്. Okay, light color. Red color is found in association with ferric compounds. Presence of ferric compounds. That ash gray color. Oh, that's one I think I mentioned. Ash gray. Ash gray color is found in areas of silica. In soil rich in silica rich soil, especially in temperate regions. Okay. Now after that, write a few words about the soil texture. Soil texture refers to what? The size of soil particles. Texture refers to size of the soil particles. So if you look at a few facts about that, just to understand just for understanding purpose, may not be asked in exam directly. Grade, coarse gravel, fine gravel, So that is one category. Maybe if you look at the soil of the Babur belt, the Babur region, all over Indian geography, the Babur region, Terai, Bangar, and Qatar. So the Babur region would be something like this. So here the diameter in millimeter would be greater than 2. This would be 1 to 2. So that is the fine gravel. We are dealing with millimeter. Then you have the coarse sand, and then you have the silt. So sand will be about 0.05 to 1. There would be various gradient. Then silt would be very fine, that is 0.002 to 0.05. So by that you mean like silt is mainly very very fine particle. Clay is becoming when it is clay. It is said to be clay when the soil is not separated from each other. Mostly you will see soil as a mixture, as a solution, or something like that. So it is, you say it is clay. So here all this is separate particles. So that is what soil, and mostly soil is a combination of soil is a combination of the sand, clay, and silt. Okay, there will be sand, there will be clay, and there will be silt. Soil is a combination of these three. Now, in every end, you will see the domination of one factor. Now, if you look at here, this will be more clayey soil, more silty soil, and more sandy soil. But anyhow, in the margins, you will be seeing whichever soil that is found in that region. But in the center, you will see mostly loam. Now, loam is a soil which is best, which are in proportion to the, which are in right proportion, about what 50 of 50 okay, in the mix. It's a mixture of loam. Loam is a mixture of clay, sand, and silt in equal ratio. Okay, now loam is the most suited for agriculture. Okay, this is loam, LOAM. Loam comes in the central part where there is balance between the presence of clay, sand, and silt. So these three should be coming together. If it is low, very clay, it's very difficult to cultivate, because it is like very difficult to plow with, plant trees, and it is even difficult for growth of roots. So that is difficult. If it is more like sandy, it would be like desert, right? So it is the loam which is very modern. So equal proportion. Loam is what? And then loam mixture of the three-part type of soil texture in equal proportion, in equal ratio. Fine. Okay, that is loam. Then you can write up a few words about soil structure. It refers to the aggregate or lump that soil particle combines to form lump, or the aggregate that the soil particles combines to form along with the organic matter. Then you have the soil acidicity, pH. pH of soil can vary between 4 to 9 usually, but usually soils are found along the 7 margin and towards the the 9 towards the basic side. But some of the soil that is found in coniferous region, like potsol soil, would be having more of കുറച്ചും കൂടെ എന്താ പറയാ acidic in nature, because of the leaves of coniferous trees are acidic. So anyhow, just remember that the pH of soil refers to the acidicity of soil, and conversely the basicity of the soil. That is what we require. Now write a few words about soil profile. Soil profile is important. So these are basic part of the soil. You are not going to be asked a long question on soil characteristics like soil texture, soil എന്താ പറയാ സോയിലിന്റെ അല്ലെങ്കിൽ സോയിൽ കളറിനെ കുറിച്ചൊന്നും ഡീറ്റെയിൽ ആയിട്ട് ആൻസർ ഒന്നും ചോദിക്കാൻ പോകുന്നില്ല. Generally സോയിലിനെ കുറിച്ച് ചോദിക്കുമ്പോൾ you can mention these much. That's why I've gone into that depth. Besides that, it is not very much important. So remember, these much are the components. Now write a few words about the soil profile in general. In general, the soil is divided into into the number of layers which are known as soil horizons. A sequence of these soil horizons are placed on the one above the other is called soil profile. Placed one above the other is known as soil profile. So this basically soil profile is talking about the vertical structure of the soil, right? So we have your shape virtual. Okay. This is the O layer. This is the A layer. O A B. This is the soil. This is the totality is known as soil profile. This is the soil or true soil. So we'll look at it detail, but initially we'll write that. This is partially weathered. Therefore, this unweathered rock. Or the parent material from which the rock has formed. Perhaps. A is the mineral layer. This is the alluvial layer. This is the alluvial layer. This is the alluvial layer. We'll see what all this stuff. Okay, and this is the layer of C is a partially weathered rock. Okay. And the A layer is basically the topsoil. A0 and A combined together is known as the topsoil. So we hear a lot of things about topsoil. When you say soil erosion, you are referring to topsoil, right? So this O layer itself can be divided into further than first one is the just a second, I go to this. Sorry about that. Very important point. Okay, so the top layer, that is the O layer. O layer is where you have this organic matter present because the litter, dead fossil fuel, fossils, leaf fossil, animal fossils, all these would be present in the top layer. And in the top, so obviously the top layer would be the most fertile because all these elements are present. So the first layer is layer of undecomposed leaves and litter. And the rest two are the layers of partially decomposed litter. Okay, so this is how you have the various layers of soil are found to be, right? Now we have to write that few words in few words. Clear? Is structure clear, right? And Baki elevation, okay, we'll study in detail as we go into it. But then we'll write a few things about this. Okay, so the O layer consists of three parts. Consists of three parts. That is the uh, two parts. You can the layer of undecomposed leaves and litter and partially decomposed litter. Please write that. Or rather, you can also say this as a layer of humification. That is I was looking for humification, where this is partially decomposed litter, and in the humified layer, this has been totally decomposed. Right. Now, talk about write about the few things like O layer is composed of mineral what is it is formed by organic matter, dominance of organic matter, and it combines it is formed of 1, 2, and 3 layers. Name them. And A layer is the layer of eluviation. Is layer of the layer of leaching and eluviation. And these two combines A plus O forms the topsoil. Now, meaning what? These are the soils where you see maximum so leaching of soil into the lower horizons is happening. Where different processes are there, where soil in the minerals are moving downwards. So there are several minerals found here, and these minerals would be moving down in different. This would be happening in a different manner in different climatic conditions, but the soil would be moving down. Okay. Now B layer is there. Okay, B layer composed of eluviation and is also a depositional layer. E layer sorry. E layer E layer is a maximum loss of material due to leaching and eluviation. This is also a layer of what you call as what you like differentiation, mineral differentiation, where mineral is carried to the bottom layers. So O, A, and E have this property where their mineral compositions are washed to the lower layers. Okay, so that is there. And here also you see dominance of coarser material. So you will see dominance of coarser material due to the process of leaching and eluviation. Okay. Sometimes after that you have the B layer, where this is stage of layer of eluviation. Eluviation meaning what? Depositional layer. So both all these layers A, E, and B are layer of erosion, where the minerals are transported downwards. Now the layer B is actually layer of elevation where depositional activities are happening. So sometimes you will see hard pan or things like Dewey crust found here. Now these are layer, hard layers formed by deposition of minerals. Okay, so correct minerals transporting. Now, the way you're looking at this soil profile is just one thing, that soil is a very dynamic entity. Soil static at there are several properties that are happening within soil, and thus based on those properties, soil are divided into different horizons, and each horizon would be having its own properties. Now, the O horizon would be, we'll see as mostly the zone where a lot of organic matter are found. Okay, and then into the A layer and the E layer, you see the what do you call as the movement of minerals that is found in the air, downward movements of air, of minerals A and E, where to the process like leaching, alluviation, you will see that. Now they are erosional layer. Now the third layer B is where the deposition of minerals which are transported down are found. There is deposition layer. Now on C layer we know it's the layer of partially decomposed rocks. So it's not exactly partially weathered rocks. It's not exactly a soil part. This soil is so it's a layer of soil formation actually. Okay, so that's how the soil is structured. In the soil is found in different horizons. So a well-developed soil region would be having this soil profile, this specifically developed profile for it. Now, if a region is not, the soil of a region is not well developed, it will mean that this differentiation of minerals would be absent. Whereas on the other hand, a soil which is well developed will be having these different layers. Soil will be found in different layers. For example, if you take alluvial soil, alluvial soil will not be having the different layers of A or especially E and B, where you will be mostly having the O layer, because every year new soil is being deposited one above the other. So there the development of soil would be limited there, and soil will be having uh, uh, the soil horizons and the soil profile would be absent there. Okay, so that is the idea about soil. Now these are the basic things about soil. Now we are more concerned about the genesis of soil, how soil is formed. Soil genesis. എന്തൊക്കെയായിരിക്കാം സോയിലിനെ അഫക്ട് ചെയ്യുന്ന പ്രോപ്പർട്ടീസ്, സോയിൽ ഫോർമേഷനെ ഹെൽപ്പ് ചെയ്യുന്ന പ്രോപ്പർട്ടീസ്? Weathering, processes. Okay, factors. Sorry. Soil forming factors. Obviously, process is weathering. Soil is formed by weathering only. So we know that. The factors that affect soil formation. Weathering is caused by
reverse.
So mostly we'll take all those factors as climatic factors. Climatic factors. Where are the
Glaciers.
Sorry? മനസ്സിലായില്ല പറഞ്ഞു.
ഈ ഡെസേർട്ടിനകത്ത് വരത്തില്ല, രാവിലെ ചൂട് കൂടുതലും പകല് ചൂട് വൈകിട്ട് ചൂട്.
അതെല്ലാം വെതറിങ് അല്ലേ? വെതറിങ് തന്നെ. അതെല്ലാം ക്ലൈമറ്റിന്റെ ഫലമായിട്ടുണ്ടാകുന്ന പ്രോസസ്. യെസ്.
Biological factors.
Yeah, biological factors would be there. Mostly vegetation. What else? Yeah, വേറെ എന്താ ഉള്ളത്? ചിലത് ഒബ്വിയസ് അല്ലെങ്കിലും yeah. എന്താണ് സൗണ്ട് ഇങ്ങനെ ബ്രേക്ക് ആയി വരുന്നത്? Yeah, പറഞ്ഞേ എന്താ പറഞ്ഞേ വോൾക്കാനിക് എന്താ എന്ത് പറഞ്ഞു?
വോൾക്കാനിക് എറക്ഷൻ സോയിൽസിന് ഒരു കാരണമാകത്തില്ലേ?
Yeah, so I'll write it as parent material. അതായത് റോക്ക് എന്തിൽ നിന്നാണോ ഉണ്ടാകുന്നത് ആ സംഭവം അല്ലെ? Weathering of rocks. So the nature of rocks that is found there, parent material. Where I think not be saying.
Chemical reactions.
അതെല്ലാം it is the function of climatic factors. Okay, so a couple of more. Just one is slope of the region. I think slope നമ്മൾ രണ്ടു മൂന്ന് പ്രാവശ്യം പറഞ്ഞ കാര്യമാണ്. So slope is there. Then there is time. Time is a major element. So these are the factors that determine how a soil is formed, or determines the different processes that are happening in the soil formation process. Now, if you look at in this one, we'll see these two as the active agents, active factors, and these two are passive factors. Active factors are those actively changes the nature of the soil irrespective of the passive factors. For example, if you take a parent rock, that is granite. Granitic soil can be converted into a red soil or also into a laterite soil, depending upon the climate. Depending upon the climate that is acting in the region, it could be converted into both either red or lateritic soil. For example, if it is heavy rainfall, say a red soil present in a heavy rainfall, hilly region would be converted into laterite soil due to silication, desilication. Silica is removed and it would be, so we'll see all this process. So these are the factors which influence the soil formation process. Now, most important one would be climatic factors. Climatic factors are of what type? Two type, basically temperature and rainfall. Temperature and rainfall are the two factors that determine what do you call as the soil formation process. Now, how these two influence temperature and precipitation? These will be influencing all the properties of soil formation that we've seen earlier, that you discussed earlier. For example, physical weathering, chemical weathering, erosion, deposition. All these are functions of climatic elements only, right? Now, soil climate helps in different ways. One, in the formation, there is accumulation of soil. Soil need to be generated and accumulated. Then there is differentiation. The soil which is developed needs to be differentiated into the soil profile. So these are the functions performed by soil. So if you look at the function of soil, there would be physical weathering in some regions. For example, the area of semi-arid region, you will mostly see physical weathering. If you see a humid regions like the rainforest, you will see more of chemical weathering. Okay, so in both these cases, the same soil can be converted into different type of soil because the climatic factors that are acting at these regions would be different. So based on the climatic action, different type of soils can be produced. Now, climatic factors would mean temperature would mean what the humid area, the hot areas or the cold areas. Maybe precipitation would mean the humid areas and the dry areas. So based on those factors, you will have different type of soils being formed. So climate is the most important factor. Climate is the one factor that is influencing the soil formation specifically. Now, accumulation would be influenced by climate. Differentiation would be influenced by climate in two types. There is earlier we have said that there is leaching, that is a downward movement, and there is also the upward movement, that is a capillary action. So with climate, the factors that are acting on the soil changes. Okay, this would be in the humid region. This would be in the dry region. Now the next element is what? So in most cases, the soil region is a reflection of the climate. Just like when we say the vegetation, there is soil, which is again a reflection of climate. But not always. There is other factors also. So for example, one matter is vegetation or the biological material. What is the role of vegetation of biological material? To provide humus content, to decide the soil texture. Similarly, soil protection. We know, like when vegetation is removed, there will be a lot of soil erosion would be there. Okay, so these are the two dominant functions or factors that determine soil formation. Now, later on, we will see what is zonal soils and azonal soils and intrazonal soils. Now, these are soils based on their development level of development of soil profile. Now, when you look at zonal soils, these are soils dominated by the active factors, active agents. Okay, climate in vegetation domination ഉണ്ടാകുന്ന സോയിൽസിനെയാണ് നമ്മൾ എന്താ പറയുക സോണൽ സോയിൽസ്. സോണൽ ക്ലാസിഫിക്കേഷനിലേക്ക് നമുക്ക് വരാം. എന്താ സംഭവം, ഇവിടെ ഈ ക്ലൈമറ്റിന്റെ ഡോമിനൻസ് കൂടുതലായതുകൊണ്ട് തന്നെ ഇലൂവിയേഷനും എലൂവിയേഷനും എല്ലാ പ്രോസസ്സും നടന്ന് സോയിലിന്റെ ഫൊറൈസിസ് വെൽ ഡെവലപ്ഡ് ആയിരിക്കും. ദാറ്റ് ഈസ് ദി റോൾ ഓഫ് vegetation and climatic factors. Now, the third one is parent material. Parent material role endana? Parent material is the first source from where obviously the soil is generated. So they are the suppliers of what? Soil components. Soil is the materials that form the soil were provided by the parent material, and this have large impact, lasting impact on soil fertility. For example, the black soil is rich in fertility because what? The basaltic rocks are able to provide highly fertile components to the soil. So soil fertility will always depend upon the parent material. Okay, and also its other natures. So this when parent material dominate, the soil would be intrazonal nature. So development of the soil formations of the soil profile would be intermediate. Okay, so we'll again come to that. We'll wait for. Then there is slope. Okay, now slope will determine the time away. Let's forget time here. Slope can be considered in two perspectives. What the aspect of slope, that is in which side the slope is situated, towards the sunlight or away from the sunlight. That would be what aspect is. Sorry. We have two things. There is aspect and direction. Now aspect is talking about the steepness or non steepness. ഒന്നെങ്കിൽ എന്തേരം steep ആണ് അല്ലെങ്കിൽ എന്തേരം steep അല്ല. So that is what the aspect. Direction will be about towards sun or against sun's direction. Now steepness ആണെങ്കിൽ എന്താണ്, highly steep ആണെങ്കിൽ less time will the soil get to remain at one place. Soil will always be moving and soil development would be very less. നമ്മളിപ്പോൾ നോക്കുകയാണെങ്കിൽ hilly regions, soil profile development is very limited because every time soil will be removed through what you call as erosion and deposition. Whereas if you look at what a region with very low slope, that comes in the aspect of drainage. In the case of very low slope and high slope, drainage is on decided. So ചെറിയ സ്ലോപ്പ് ആകുമ്പോൾ വലിയ സ്ലോപ്പ് ആകുമ്പോൾ പെട്ടെന്ന് റോഡ് ചെയ്ത് കളയും, സോയിൽ ഡെവലപ്പ് ആകത്തില്ല. ഇനി വെരി ലോ സ്ലോപ്പ് ആണെങ്കിൽ എന്താണ്, വാട്ടർ ലോക്കിംഗ്. ഒരു ചതുപ്പ് നിലം എടുക്കുക, ചതുപ്പ് നിലത്ത് എന്തായിരിക്കും, അവിടുത്തെ സോയിൽ വേറെ രീതിയിലായിരിക്കും. സോയിൽ വുഡ് ബി വാട്ടർ ലോക്ക് സോയിൽ. സോ ദിസ് ഈസ് അഗെയിൻ feature of intrazonal soil, where the climatic influence is overshadowed by other factors. Right. Now the last one is type. For climate to act and for proper development of soil, you need a long time period for that soil to develop into the horizons or the profiles. അല്ലെ, കുറെ സമയം എടുത്താണ് സോയിൽ അവിടെ കിടന്ന് അതിന്റെ ഇലൂവിയേഷൻ ഒക്കെ നടന്ന് ആണ് സോയിൽ ഒരു soil development. Okay, the climate act and other elements has to act on that. But in some soil, time is not available for soil formation. For example, if you look at the alluvial soil, every year new soil is being deposited above the old soil. So there ain't much time for the different layers to develop. Soil formation process സമയം കിട്ടത്തില്ല. So there is no soil profile. Soil profile is not developed. So there is a zonal arrangement of soil and soil, different layers of zones. That is, horizons of soil is absent. Such a soil would be a zonal soil. So these are the factors. So time എന്ന് പറയുന്നത് ഒരു active factor അല്ല. Time is basically, time either allows the climatic factors to act or time does not allow the climatic factors to act. So that's the role of time. So this is how we can see the different factors that is affecting the formation of soil. I'll just dictate it. I hope you got it. Climate ആണ് ഏറ്റവും പ്രധാനപ്പെട്ട ആക്ടർ. ഒരു ക്ലൈമറ്റ് വെച്ചിട്ട് ഒരേ പേരന്റ് മെറ്റീരിയലിൽ, ഒരു സിംഗിൾ പേരന്റ് മെറ്റീരിയലിൽ ഉണ്ടായ റോക്കിനെ നമുക്ക് രണ്ട് ഡിഫറെന്റ് എന്താണ് സോയിൽ ടൈപ്പ് ആക്കി മാറ്റാം. ഓക്കെ, ഇനി അതിന്റെ പുറത്തോട്ട് വെജിറ്റേഷൻ ആഡ് ചെയ്യുമ്പോഴാണ് അതിന്റെ ന്യൂട്രീഷനും അതിന്റെ ടെക്സ്ചറും ഒക്കെ മാറുന്നത്. ഇനി ഇത് രണ്ടും ആക്ട് ചെയ്യുന്നതിന് സമയം വളരെ പ്രധാനപ്പെട്ട കാര്യമാണ്. സമയം ഇല്ലെങ്കിൽ ഇത് രണ്ടും മര്യാദയ്ക്ക് ആക്ട് ചെയ്തില്ല, സമയം കിട്ടത്തില്ല. ക്ലൈമാറ്റിന് വേരിയേഷൻ വരുത്താനും വെജിറ്റേഷൻ ആഡ് ചെയ്യാനുള്ള സമയം കിട്ടില്ല. അതുപോലെ തന്നെ സ്ലോപ്പ് നിങ്ങൾ എടുക്കുകയാണെങ്കിൽ, സ്ലോപ്പിനകത്തും സ്ലോപ്പ് സ്റ്റീപ്പർ ആണെങ്കിൽ again soil development will be very less because the soil every time will be removed, eroded. Now soil അതേസമയം സ്ലോപ്പ് ഇല്ല, വാട്ടർ ലോഡ് സിറ്റുവേഷൻ ആണെങ്കിലോ soil development will be again change because വെള്ളത്തിനടിയിൽ കിടക്കുകയാണ്, വാട്ടർ ലോഡ് കണ്ടീഷൻ ആണ്, ഓക്സിജൻ വ്യത്യാസമുണ്ട്, ഫെർട്ടിലൈസർ കുറവുണ്ട്, ഫെർട്ടിലൈസർ അല്ല മിനറൽ കമ്പോസിഷൻ കുറവുണ്ട്, അതുപോലെ ഡീകമ്പോസിഷൻ വ്യത്യാസമുണ്ട്. സോ again the property of soil changes. ചതുപ്പ് നിരത്തെ സോയിൽസിന് വേറെ പ്രോപ്പർട്ടിയാണ് PT soil. Maybe sometimes you develop carbon rich PT soils when you are under waterlogged conditions. Okay, so these are the cases when അതുപോലെ തന്നെ നമുക്കറിയാം, ഇപ്പോൾ നമ്മൾ GS കണ്ടിട്ടുള്ള എക്സാമ്പിൾ ആയിരിക്കണം, salinity of soil കണ്ടിട്ടില്ലേ, salinization alkalization in Punjab region. Why? How is Punjab region salinization alkalization നടക്കുന്നത്? ഇറിഗേഷൻ. അപ്പൊ നമ്മുടെ ഈ പറഞ്ഞ ഫാക്ടേഴ്സ് അടുത്ത് കണക്ട് ചെയ്ത് നോക്കിയേ, ഏത് ഫാക്ടർ അവിടെ ആക്ട് ചെയ്യുന്നത്? പറഞ്ഞു ഏത് ഫാക്ടർ ആക്ട് ചെയ്യുന്നത്? ഗസ് ചെയ്ത് ടൈമില്ല. സ്ലോപ്പ് ആണ് അല്ലെ? എന്താണ്? വെള്ളം കെട്ടിക്കിടക്കുകയാണ്. വെള്ളം കെട്ടിക്കിടന്ന് ഒരേ നേരം കെട്ടിക്കിടന്നിട്ട് ആ സലൈൻ ആയിട്ടുള്ള പാർട്ടിക്കിൾസ് മുകളിലോട്ട് വരാൻ തുടങ്ങുകയാണ് ചെയ്യുന്നത്. ഫോൾട്ടി ഇറിഗേഷൻ ആണ്. കുറച്ച് ഇറിഗേഷൻ, ആവശ്യത്തിന് ഇറിഗേഷൻ കുറച്ച് സമയത്തിന് ചെയ്യുവാണെങ്കിൽ കുഴപ്പമില്ല. ഓക്കെ, അപ്പൊ സ്ലോപ്പിന്റെ എലമെന്റ് ആണ് ഇവിടെ പ്രശ്നമായിട്ട് വരുന്നത്. അതിപ്പോ സ്ലോപ്പ് നമുക്ക് പ്ലെയിൻസിലായതുകൊണ്ട് ഒഴുകി പോകുന്നില്ല എന്ന് പറയാം, അല്ലെങ്കിൽ എന്തായാലും സ്ലോപ്പ് ഫെയിലിയർ ഉണ്ട്. കെട്ടി നിർത്തുവാണെങ്കിലും നമുക്ക് അത് തന്നെ പറയാം, സ്ലോപ്പിന്റെ ഫംഗ്ഷൻ ആണ് ഇവിടെ വരുന്നത്, വാട്ടർ ലോഗിങ് ആണ് വരുന്നത്. ഓക്കെ, ഫെയർ എനഫ്. അത്രയും കാര്യങ്ങളാണ്. ജസ്റ്റ് നമുക്ക് എഴുതാം, ഇച്ചിരി എഴുതാനുണ്ട്. Factors controlling soil formation heading. Primary factors ആയിട്ട് climate and vegetation എഴുതുക. You will have zonal soil. Zonal classification നമുക്ക് പഠിക്കാം കേട്ടോ. Zonal soil. Parent material and slope of the region. Intrazonal. And this is a zonal. Zonal soil. Okay, now let's see. First factor, that is climate. Climate is the most potent factor in soil formation. Climate is the most potent factor in soil formation, starting from the process of weathering, from weathering to differentiation of soil horizons. For example, the type and rate of weathering is determined by the soil found, the climate found in the region. So there is even a diagram that we usually draw. I don't think that is usually that's of much utility here, but I'll just show you how this diagram is drawn. Okay. Basically representing the relationship between temperature and rainfall. Low, high, low, right. In regions of high temperature and high precipitation, you have high chemical weathering. Then you have the other regions, just like that. Just you can draw. Sometimes you can use this. Okay. Moderate physical weathering plus chemical weathering. ഈ ലൈൻ കുറച്ച് കുഞ്ഞായിട്ട് ഇടാൻ പറ്റും. Okay. Moderate physical weathering, high physical weathering. Okay, and these are the regions generally absent. So here you have slight physical weathering plus chemical weathering, moderate chemical weathering, and what here again moderate chemical weathering. Right. So this is something we draw with respect to now. You don't have to study this particularly in detail. I'm just showing you how this is done. So you have the high temperature and high rainfall region. Okay, that is the tropical region. So if you look at the tropical rainforest, you see what there is very high temperature and temperature variation is very limited. Right, temperature variation is very limited. So physical weathering obviously is more active when there is high temperature variation. But on the other hand, high temperature and high rainfall, high moisture condition and high temperature would mean what? Lot of chemical activities, lot of bacteria, lot of reactions happening. So chemical weathering would be dominating. On the other hand, when you look at the higher polar regions, you have here a situation where there is physical weathering is very high because temperature variation between seasons, freezing, thawing, all these are very significant. So physical weathering is very high. On the other hand, chemical weathering, if you look at it, rain would be less. Similarly, temperature would also be low. So biological activity will be low. So based on the climate of that particular region, that is the temperature and the rainfall, the type of weathering processes varies. Fine. മനസ്സിലായില്ലേ? Yes or no? Yes or no? Hello, മനസ്സിലായോ?
That's like sir.
Okay. Yeah. By the type of climate found in the region. So you can take an example of maybe two regions, maybe tropical region and the difference between tropical and polar regions can be written. In the it also determines other characteristics of the soil such as it also determines other characteristics of soil such as the soil's texture, soil texture, example where physical weathering is dominant, where physical weathering is low, is maximum, or the regions of physical weathering. High physical weathering means what? Coarse soil, coarse texture. That will mean what? Low water retentivity. അല്ലെ സോയിലിനെ എപ്പോഴും ചെറിയ പാർട്ടിക്കിൾസ് ആക്കി മാറ്റുന്നത് കെമിക്കൽ വെതറിംഗ് ആണ്. Physical weathering would be forming larger soils with larger size. So coarse soils will be dominating in the physical weathering നടക്കുന്ന സ്ഥലങ്ങളിൽ. And when that is the case, when the soil is very coarse, water retain ചെയ്യാനുള്ള capacity will be very less because the soil, there will be huge gap between, or the gap between the soil will be larger and the water retentivity of the soil changes. So again, another property of the soil has changed because of the climatic conditions prevailing in that region. Okay, so texture would be coarse and water retentivity would be low. Similarly, climate plays a major role in the process of in the process of differentiation of soil formation. Okay, in humid region, it will be characterized by what? Downward movement, or you can say elevation, leaching. In dry region, it would be characterized by what? Capillary action. That is upward movement. Through capillary action. So again, in a particular region, what kind of differentiation activity, whether it is upward or downward movement, would be determined by the climate of that region. So again, climate now. So if you look at humid region, it would be precipitation would be greater than evaporation. In dry region, precipitation would be less than evaporation. When precipitation is greater than evaporation, more water would be going down. Evaporation so vellam net when more vellam goes down, it would lead to more leaching. On the other hand, when precipitation is less than evaporation, what happens? Water next movement would be towards the atmosphere, and then so water will move up, and capillary action. When that water is moving up, it will also bring the minerals from the lower horizon to the upper horizon. Water would be lost, or rather water would be lost, but mineral movement is from one to the down, one to the bottom, and one to the top. So obviously, based on the nature of mineral movement, if minerals more are found in the upper soil, it will be having one property compared to the mineral found in the lower portion. So that is basically how climate is acting on mineral differentiation. So almost all properties of soil is affected by climate. We've seen that. Now the next point is vegetation. Vegetation too plays an important role. Vegetation also plays an important role in soil formation. It provides organic matter. Most importantly, it provides organic matter to the soil. Most important role is providing organic matter to the soil. Besides, it also impacts the rate of weathering. Thus, soil vegetation has an important role in accumulation of both organic and inorganic minerals. in the soil. So രണ്ട് പ്രോസസ് ആണ് നമ്മൾ പറഞ്ഞത്. ഒന്ന് മിനറലൈസേഷൻ ഓഫ് സോയിൽ ഫോർമേഷൻ, രണ്ട് പ്രോസസ്സുകളാണുള്ളത്. ഫാക്ടേഴ്സ് അല്ല, പ്രോസസ്. വൺ ഈസ് അക്യുമുലേഷൻ ആൻഡ് ദി നെക്സ്റ്റ് ഈസ് ഡിഫറൻസിയേഷൻ. സോയിൽ എങ്ങനെ ജനറേറ്റഡ് ആയി അക്യുമുലേറ്റ് ചെയ്യുന്നു, രണ്ട് ആ അക്യുമുലേറ്റ് ചെയ്ത സോയിലിന്റെ പ്രോപ്പർട്ടീസ് എങ്ങനെ മാറുന്നു, മിനറൽ പ്രോപ്പർട്ടീസ് മാറുന്നു. സോ വെജിറ്റേഷൻ നമ്മൾ ക്ലൈമറ്റിന്റെ കാര്യത്തിൽ രണ്ട് ക്യാരക്ടേഴ്സും കണ്ടു. ഇനി വെജിറ്റേഷന്റെ കാര്യത്തിലാണെങ്കിൽ ഓൾറെഡി വി ഹാവ് സീൻ ഹൗ അക്യുമുലേഷൻ ഈസ് ഇൻഫ്ലുവൻസ്, വൺ ബൈ providing organic matter and the other by determining the rate of weathering. For example, if weathering നോക്കുകയാണെങ്കിൽ region which is covered by vegetation would be having less weathering generally, but there would be vegetation root ഒക്കെ വെച്ചിട്ടുള്ള weathering process ആണ്. But if a region is without what you call as vegetation, there would be more weathering happening because the soil would be exposed to more agents of erosion or weathering, right? It's a next point. Vegetation certainly improves the texture of the soil. Vegetation improves the texture of the soil through biological weathering. Certainly improves the texture of the soil through biological weathering. For example, ഇപ്പം earthworm ഒക്കെ നോക്കിക്കഴിഞ്ഞാൽ it's the best example. How weathering നടത്തി അതിന്റെ ടെക്സ്ചർ ഫൈനർ ആക്കുന്നു. സോയിലിന്റെ earthworm is basically what naturally plowing, natural plower of the soil എന്ന് പറയാറുണ്ട്. So it is basically modifying its texture. Soil particles combined with organic matter. Soil particles combines with organic matter furnished by the vegetation. Soil particles combined with organic matter furnished by the vegetation to form different structures. Different structures like blocky, platy, crumbly. You have seen earlier, na? I just mentioned that. So our different structures എന്താണ് ഓർഗാനിക്കും ഇനോർഗാനിക്കും തമ്മിലുള്ള ഇന്ററാക്ഷൻ ഫലമായിട്ട് ഉണ്ടാകുന്ന different structures which, so structure ബ്രാക്കറ്റിൽ വന്നിട്ടു blocky, platy, crumbly. Different structures which have major impact upon characteristics like permeability, fertility, ease of cultivation, etc. Further, it helps in retention of soil by binding the soil particles together. Further, it helps in retention of soil by binding soil particles together and reduces runoff. Water runoff by inducing more infiltration. Okay, so that's the role played by vegetation. Very important. These are the two active factors. Now you look at we can look at some of the passive factors. First one is parent material. Parent material can also control the rate of weathering. Depending upon factors like type of rocks involved, their composition, their arrangement, and other characteristics like porosity and permeability. Now, if you look at it again, some of the rocks are easily degradable. For example, basaltic rocks are generally easily erodible compared to other igneous rocks like granite. On the other hand, if you look at sedimentary rocks, it is even more easily happens to be weathered. Weathering is fast, erosion is fast, so everything is fast. Whereas granitic rocks are very tough. Now, similarly, if you look at different type of arrangements, like maybe a folded region, faster erosion. Maybe if the rock is buried under soil, lesser uh, erosion or weathering and soil formation would be there. So depending upon this property, it changes. Okay, fine. In fact, it is the parent material which supplies the inorganic content to the soil. And depending upon the composition of the parent material, mineral composition of the soils also changes. Example, if you look at calcareous soil, calcareous soils are formed due to the domination of limestone rocks. Right, limestone rock region, limestone rock erode ചെയ്ത് കഴിയുമ്പോൾ ഉണ്ടാകുന്ന സോയിലിനകത്ത് കൂടുതലും കാൽഷ്യം കണ്ടന്റ് ഭയങ്കര കൂടുതലായിരിക്കും. So you see calcareous rocks soils. These are also the part of the intrazonal soils. We'll see that again. We'll see them again. Intrazonal വരുമ്പോൾ നമുക്ക് ഒന്നുകൂടെ പറയാം എങ്ങനെയാണ് parent material influence ചെയ്യുന്നത്. Now the fourth one is the slope or the topography. Topographical factors like angle of slope, and direction of slope angle of slope and direction of slope also have a major say in soil formation. Okay. Formation in the areas of steeper slope. In areas of steeper slope, soil profile is found to be thin. Soil profile is found to be thin. As mass wasting is much more faster. As mass wasting is much more faster on such slopes. On the other hand, in areas of very flat topography, and defective drainage, waterlogging would result in would result in the creation of anaerobic soil or anaerobic conditions. Oxygen less conditions, anaerobic conditions would result in the creation of anaerobic conditions leading to formation of organic soils. Another point is that the direction of slope is equally important. The direction of slope determines whether the direction of the slope, in which direction the slope is slanting, would determine whether the slope faces sun or if it's the windward side, etc. Again, it's clear. So here we will be having skeletal soil, and here there would be maybe there could be waterlogging. So it varies with region. So the waterlog, if you look at the Sundarbans region, we have what kind of soil there? Soil online. നമ്മുടെ GS
സാർ വോയിസ് കേൾക്കുന്നുണ്ടായിരുന്നേ. സാർ വോയിസ് കേൾക്കാൻ പറ്റത്തില്ല. ഹലോ
ഓക്കെ, എവിടെ വരെ കേട്ടെ?
സാർ ആ സുന്ദർബന്റെ കാര്യം എന്തായിരുന്നു?
ആ, സുന്ദർബൻസിലെ സോയിൽ എന്ത് ടൈപ്പ് ആണ്?
അലൂവിയൽ അല്ലേ?
അല്ലല്ലോ. അലൂവിയൽ സോയിൽ അല്ലല്ലോ. എന്തോ
സിൽട്ടാണ്
അല്ലല്ലോ. നമ്മൾ വേറൊരു പേര് പറയൂലോ ആ മാപ്പിനകത്ത്. ജോഗ്രഫി ബുക്കിൽ വേറൊരു പേരാണല്ലോ കൊടുത്തിരിക്കുന്നത്. Okay, littoral soil. Littoral or peat soil. Okay, because alluvial soil ആയിരുന്നേനെ, പക്ഷെ water logged condition ആയതുകൊണ്ട് അതിന്റെ നേച്ചർ മാറിയിട്ടുണ്ട്. So NCERT അത് littoral soil ആണ് കൊടുത്തിരിക്കുന്നത്. Okay, so that is different. Now, okay, then that's impact of topography, because there is water logged condition ആയതുകൊണ്ട് തന്നെ ഒന്ന് mountain soil നമ്മൾ കണ്ടിട്ടില്ല. Mountain soil is ചിലടത്ത് mountain soil പറയും, because that is of the peculiar slope conditions. In some other places where the slope is very defective, the drainage is defective, you see what you call as peat soil. Okay, marshland ഒക്കെ കാണുന്നത് soil ആണ്. Now time determines the duration for which the soil forming processes have operated. The duration for which the soil forming processes have operated, and thus ultimately determines the characteristics like thickness of the soil profile, differentiation of the horizons, etc. For example, for the soils in sand dunes, soil profile is absent. Similarly, in Kadar region, in the recently formed Kadar region, soil profile would be absent. That differentiation has not taken place. That's the difference. Okay. The next element is what we have to look at, the process of soil formation. Okay. Soil formation is composed of basically two processes. Soil forming process. One is soil accumulation. The second one is soil differentiation. Now, accumulation is a function of weathering, erosion, deposition.
സാർ ടാബിൽ എഴുതുന്നത് കാണാൻ പറ്റുന്നില്ല കേട്ടോ.
Sure. Screen share ആയില്ലേ? Sorry. Okay. Soil forming processes comprised of soil accumulation and soil differentiation. ഒന്ന് soil accumulate ചെയ്യണം, രണ്ട് ആ accumulate ചെയ്ത soilനെ എങ്ങനെയൊക്കെയാണ് differentiate ചെയ്യുന്നത്, ഈ രണ്ട് രീതിയിലാണ് നടക്കുന്നത്. Soil ഫോർമേഷനിലേക്ക് വരുമ്പോഴത്തേനും first one is weathering. Weathering is soil erosion or deposition. Okay, deposition plus the vegetation elements. Vegetation എങ്ങനെയാണ്? Vegetation separate എഴുതുന്നില്ല. These are the three purposes in which that is happening. One more element that is there is humification. How this vegetation that has been brought, vegetal component that has been brought is changed through decomposition of the soil. So these 3-4 processes combines together to form or to accumulate the soil. Okay. Now that is soil formation process. Now once the soil is formed, soil differentiation would be happening based on the climatic factors. The different minerals would be rearranged based on the elements of climate that is acting in a particular region. ഇത്രയും കാര്യങ്ങളാണ് will lead to soil formation. Now you will see the different factors that are leading to soil formation or the processes that are happening. Okay, processes to soil formation. And largely speaking, there are two type of soil formation processes. That is the one in. Okay, I'll come to that. First, let's write the soil forming processes that are happening. Okay, alluviation. First one is alluviation. Okay, so alluviation refers to mechanical downwasting of particles in suspended form. Mechanical downwasting in suspended form. In suspended form, along with water percolating downwards. Along with water percolating downwards. Okay. In general, these are finer particles these are finer particles which are elevated from the soil. Due to this process, E horizon is differentiated from the A horizon. Due to this process, the E horizon is differentiated from the A horizon. So one thing to remember is that eluviation is acting in a mechanical downwasting of uh, minerals. And the process is dominant in humid climates where rainfall is greater than evaporation. Process is dominant across humid climates where rainfall is greater than precipitation. Now the next one is leaching. It's a movement of organic matter soluble bases, etc. in dissolved form movement of organic matter soluble bases, etc. in dissolved form with water downwards, along with water downwards. Okay, that is leaching. Now the third one is eluviation. I-double-L-U-V-I-U-V-I-T-I-O. Eluviation. The soil materials eluviated from upper horizons gets deposited in the B horizon. Elevated from the B horizon, from the A horizon or B horizon, get deposited in the B horizon, and the process is known as eluviation. Okay, so three processes are there. Capillary action, need not right because capillary action is familiar. Water rising up. Now, this process can be classified into two categories. That is the humid climate, where it is happening in a humid climate, and where that is happening in the dry climate. Humid climate, you have this eluviation, leaching is happening. In dry climate, basically this is basically what precipitation greater than evaporation. And here precipitation is less than evaporation. So that is the difference, the main difference. Now here you would be seeing capillary action, salinization, or alkalization. Okay, so that is dry climate. Now then in the humid climate itself, you have two kinds of humid climate. That is the warm tropical climate or the cold temperate climate. Now in these two climates, the processes that are acting on the region varies. Now in tropical region, there is a process of desilication. That is, silica is what that is leached. In cold temperature, it is a process of this is also known as lattice solarization. Desilication. Here, the process of silication, because silica is what that the soil becomes rich in silica. Here, silica is not leached or eluviated, but rather other minerals are eluviated. So here, this is known by the name podsolization. Okay, podsolization. So these are the two kind of activities that are happening in these regions. Now, if you look at desilication here, the soil horizon is there, the upper soil horizon is there, and there are several type of minerals. And here mostly you see silica, aluminium, Fe, etc. Other minerals, organic minerals are there. Of these, all these are organic. The silicon minerals are leached out. Okay, and then this is what left behind: aluminium and Fe. So that is a process of desilication. It is removed. Silica is removed from the soil. Now, when silica is extremely removed, aluminum is get concentrated, you have the laterite soil. So first there is desilication, and when desilication is carried out for longer period, you get what the soil rich in iron and aluminum. That is called as a process of laterization. Okay, laterization happens in few limited areas. Generally, desilication is a process that is happening in the tropical belt. Now, in overall. Now, on the other hand, you have the process of podsolization. Now here, what silica is not taken away. Okay, there is a process of chelation. You know, we have coniferous trees, right? Now, when these coniferous trees falls down, they slowly disintegrate and they make an acidic solution. So that is the acidic soil, acidic material. That is process of chelation. In chelation, what happens? The Fe, Al, all these things are soluble and leached. Leaching happens, which is leading to the what with silica remaining in topsoil. Okay, so here the chelation is a process. Here it is desilication because of high water, high rainfall. So in these two cases, both are humid region, but the processes of downward movement of the soil minerals varies, and based on that you have one which is rich in soil silica and the other which is deficient in, or rather desilicized. So that's the variation between these two. So we'll first write these two. Let's first write podsolization. So first of all, draw this diagram. Okay, the dictate draw this much. Okay. Podsolization or silication. First one. In coniferous forest zones, chelating agents or chemicals. Chelating. Acidic. Form agents or chemicals are found in the leaves of coniferous trees. These chelates, which are later combines with later combines with Fe and Al, iron and aluminium of soil to convert them into chelation or another chemical process. A process in a leaves are which is acidic. So to convert them into soluble silicosoids. Silicosoids of aluminium and iron. So they are soluble, right? And when rainfall happens, they dissolve in soil. The soils get enriched. These silicosoids are leached out of the soil. These silicosoids are leached out of the soil along with bases and organic content. Thus, the soil gets leaving behind silica in the topsoil. We have to draw a diagram. organic, FeAl, silica. All these are taken down. Silica remains. Okay. The soils get enriched in silica and it becomes acidic because of the leaching of the bases, and becomes acidic because of the leaching of bases. Due to this high silica content, the soil becomes whitish or ash gray in color, whitish or ash gray in color. Such soils are called as potsol soils. Potsol soils, and also the process is known as potsolization. Potsolization. Now the next one is desilication. We have explained that too also, right? Desilication has been explained. Yes. In tropical climate, so the process of potsolization happens in cool climates, cooler climates. In desilication and laterization. In tropical climate, silica becomes highly mobile and are leached out of the soil. Highly mobile and are leached out of the soil due to heat and അതുകൊണ്ടാണ് highly mobile ആകുന്നത്. But അതിലേക്ക് നമുക്ക് പോകേണ്ട കാര്യമില്ല. Leached out of the soil along with organic matter and bases. Leached out of the soil along with organic matter and bases. Thus the soil becomes enriched in Fe and Al. Here Fe and Al. മറ്റൊരു Fe and Al പോയി ഇവിടെ Fe and Al rich ആയി. Enriched in Fe and Al, and the process is called desilication. Desilication of soil. If desilication occurs over a long period under circumstances of highland location and alternate wet and dry climate, the conditions of highland topography and or alternate wet dry climate, intensive leaching takes place. Leaching takes place along with baking of the soil breaking of the topsoil, baking of soil during the dry season. Such process is known as laterization. വെട്ടുകൽ ഫോം ചെയ്യുന്ന പരിപാടി ഇതാണ്. So വെട്ടുകൽ എന്താണ്? സോയിലാണ്, സോയിൽ ലാറ്ററൈറ്റ് ആയി മാറിയിരിക്കും. So it appears more like a hard brick surface. Okay. The last one, that is the capillary process, or the process that is happening in the dry region. So here what is happening? There are different layers, and from the lower layer, calcium is rising up. So the calcium that is found beneath is rising up, and the calcium concentration or salinity salt concentration on the topsoil is increasing. Okay, and that is not very good, but anyhow we will see. In arid and semi-arid regions, the process of capillary process of salinization and alkalization. In arid and semi-arid climates, the groundwater rises through capillary action. Groundwater rises through capillary action towards the surface. As it reaches the B horizon, after it reaches the B horizon, it begins to evaporate, leaving behind. It begins to evaporate, leaving behind the salts that are dissolved in this water. Thus, salts are deposited in the soil, and the process is known as salinization. Okay, so this is what happens. The water from the water table will rise up, and it will be deposited. The salt will be deposited as and when the water turns into vapor. Vapor cannot carry salt, right? So even in the case of our, soil, the water drain, this is what happens. So water would be given, water would be going in, but this water will not remain as water for long, because this water is what it start to evaporate, because it's a very arid region. Evaporation is greater than precipitation, and when this water precipitate, this water would be definitely having several type of minerals. And when the water is evaporated, the minerals will still remain in the land. And the more the water you are providing and the water is evaporating, the more salts will be left behind in the region. And this salt then increases. When the proportion of the salt or the alkali increases, also there would be the groundwater rising up. They will also add more salt to the region, and this will result in finally in the issue of salinity or salinization or alkalization of the soil. Okay. Now, when this condition is present across the world, in the sense that in all the dry regions, these processes would be happening. As the dryness increases, there are several types of soil. So, for example, there is Chernosem soil, there is chestnut soil, there is desert soil, where these phenomena are happening. And finally, there will be saline alkaline soil. So, when we introduce these conditions, which are not natural, because Punjab വെള്ളം കിട്ടുന്നത് natural ആയിട്ട് പരിപാടിയല്ല. അപ്പോൾ അങ്ങനെ extra വെള്ളം കൊടുക്കുമ്പോൾ ഇതിന്റെ balance keep ചെയ്യും. So these are basically soils with a capillary action. Chernosem, chestnut ഇതുപോലത്തെ soil ആണ്, which is good for grass growth. Grass, just wheat is a grass, rice is a grass. But when the proportion increases, it becomes a desert or saline alkaline soil. അപ്പം നമ്മളിപ്പോ പഞ്ചാബിലെ ചില സ്ഥലത്തുള്ള സോയിൽ നോക്കുകയാണെങ്കിൽ സോയിലിന്റെ മുകളിൽ ഇങ്ങനെ വെള്ള നിറത്തിൽ സോൾട്ട് ഇങ്ങനെ കിടക്കുമായിരിക്കും. ഡിഫറെന്റ് ടൈപ്പ് ഓഫ് സോൾട്ട്സ് ഇങ്ങനെ ഡെപ്പോസിറ്റ് ആയി കിടക്കുമായിരിക്കും. അത് ഈ ഒരു ബാലൻസ് ബ്രേക്ക് ചെയ്തതിന്റെ പേരിലാണ്. So these are the process. In natural conditions, these are okay, no problem. But alteration will lead to degradation of the soil. So this is a process in which different types of soil are formed. Now we have seen three types of soil, basically pot soil, lattice soils, and the saline alkaline soil. Okay. നമുക്ക് ഒരു ഇതിന്റെ ബേസിൽ സോയിൽ ഒന്ന് ക്ലാസിഫൈയും കൂടെ ചെയ്യണം, which we'll do in the afternoon session. Okay. Cool. മനസ്സിലായോ? Okay അല്ലേ? അന്ന് നമുക്ക് കൺക്ലൂഡ് ചെയ്യാം. 3:53 okay, and we'll assemble back at 6 o'clock. നാളെ എന്താ പരിപാടി? നാളത്തെ പരിപാടികൾ എങ്ങനെയാ? ക്ലാസ് ഉണ്ടോ?
ക്ലാസ് ഒന്നും ഇല്ല.
നാളെ വെച്ചാലും ക്ലാസ്
അല്ല, ബാക്കി ആൾക്കാർ വരട്ടെ, ഞാൻ പറയുന്നില്ല.
തല ചെയ്തിട്ടാണ് കിട്ടി. ഓക്കെ, ബാക്കിയുള്ള അഭിപ്രായം എന്താണ്?
സർ, മൺഡേ ഞങ്ങൾക്ക് എക്സാം ഉണ്ടായിരുന്നു.
മൺഡേ എക്സാം ഉണ്ടല്ലേ? ഓക്കെ. എന്താ ഒരു ക്ലാസ് വെക്കണോ അതോ നാളെ ബ്രേക്ക് വേണം ഉദ്ദേശിച്ചത്? ഒരു ക്ലാസ് വെച്ചാലോ? 6 o'clock something. ബ്രേക്ക് ആണ് സിബിനെ, ക്ലാസ് കഴിഞ്ഞാ ഇപ്പൊ ബ്രേക്ക് വെക്കാം. ഇതൊന്നും തീരുമാനമായി കഴിഞ്ഞാൽ ഇപ്പൊ ബ്രേക്ക്. എന്താ പറഞ്ഞത്?
അത് എല്ലാവരുടെയും എനിക്ക് കുഴപ്പമില്ല. നാളെ ഒരു ക്ലാസ് ആണെങ്കിൽ കുഴപ്പമില്ല.
ഓക്കെ, സിബിൻ നാളെ ബ്രേക്ക് വേണമെന്നാണ് ഉദ്ദേശിച്ചത്. ഓക്കെ, ബ്രേക്ക് ബാക്കിയുള്ള ഒരു ക്ലാസ് വെക്കാന്നാണ് എന്റെ അഭിപ്രായം. അല്ലെങ്കിൽ പിന്നെ നീണ്ടു പോകത്തില്ല. അതാണെങ്കിൽ നമുക്ക് ഈ ഒരാഴ്ച കൊണ്ട് തന്നെ ഫിനിഷ് ചെയ്യാം.
ഒരു ഉച്ച കഴിഞ്ഞിട്ടാണെങ്കിൽ കുഴപ്പമില്ല.
ഉച്ച കഴിഞ്ഞിട്ടല്ലേ?
രാത്രിക്ക് വെക്കാനല്ല, ഒരു ഉച്ച കഴിഞ്ഞിട്ട്.
ഓക്കെ. പിന്നെ ഉച്ച കഴിഞ്ഞ് ഓക്കെ ആയിരിക്കും? പെട്ടെന്ന് തീർക്കായിരുന്നു. ഓക്കെ, എന്നാ ഒരു സമയം കൂടെ നമുക്കൊരു ഈ ഒരു സമയം 2 o'clock to 4 o'clock.
മതി. അല്ലെങ്കിൽ 1:30 വെക്കാൻ ചെയ്യാം, കുഴപ്പമില്ല. 3:30 മതി.
ഓക്കെ, ആയിക്കോട്ടെ. 1:30 to 3:30. ഓക്കെ, എന്നാ ശരി. അപ്പൊ നമുക്ക് ഉച്ച കഴിഞ്ഞ് 6 മണിക്കാണ്. ബൈ. ശരി.
ഓക്കെ സാർ, താങ്ക് യു.
ഓക്കെ.